Before we end this module, let's discuss a common question asked by many students concerning p-n junctions. Carriers experience a built-in potential at the junction. Can this voltage be measured externally? To answer this question, let's first consider a system consisting of a p-type material, an n-type material, and two different kinds of metals, M1 and M2, as connecting wires. Assume each material has its own potential. Whenever two different materials are put into contact, potential differences will be developed between the two different materials as a result of their potential difference. So, if we want to find out the potential difference between points A and B, it is just equal to the sum of all individual potentials, which is given by Vm1 minus Vp plus Vp minus Vn plus Vn minus Vm2. All the internal voltages will be cancelled, and the measured potential is only the potential difference between the materials at the two ends. Now, if you use a voltmeter to measure this potential, the voltmeter has to probe the points with some metal lines, let's say made of a metal M3. So, the measured potential difference at the voltmeter will be the potential difference between M3 and M3, which is 0. If you use different materials for the two ends of the voltmeter, you are just measuring the voltage difference between these two materials instead of the potential difference between point A and point B. The phenomenon can also be explained with the Venn diagram. Assume you are connecting the two sides of a p-n junction by a perfect superconducting wire that allows carriers to move freely. It is like connecting the p side and n side directly on the other ends. Then a junction will be formed. And the internal potential will be balanced by the voltage changes at the contact that no external voltages can be measured. So the conclusion is the built-in potential is internal to the p-n junction and cannot be measured externally. It may take some time to comprehend what is going on, but the general idea has been given. I hope you can eventually grasp the idea.